There is a specific special case with law of sines called the ambiguous case. This happens if you have two sides and the angle not in between them. So for example, like if you were given this angle right here, like this alpha angle, then that wouldn't be a problem. The angle has to be the other angle, like not in between them. So there are a couple of cases that happen. This could be a case to where there is no solution, meaning that the triangle is not even possible to happen. You could get a case to where there was a right triangle to where you're going to have only one solution based because it's a right triangle. And then you could have the case to where the arm could actually swing out and you could actually have two solutions. And what could happen is if you have one angle or one side that creates, it's the same distance of the A, B, and this alpha, but this angle A possibly could have swung out and created an obtuse triangle. So if this was an acute, it also could swing out and become an obtuse triangle. So here's how you determine how many answers you could possibly have. So for example, we have a situation. I'm going to create a triangle. Let's let this be B. This is 61 degrees. Let's let this be angle A, which means little a is 35 and little b is 32. We don't know C. We automatically know that there is an angle in its opposite side, so we can automatically go ahead and try to find angle A. So the sine of 61 divided by its opposite side is going to equal the sine of A divided by its opposite side. When you cross multiply, and divide, when you will get 0.9566 for the sine of A. Anytime you're trying to find an angle, this is where you take the inverse. So the inverse of sine of 0.9566 is going to be 73.06 degrees. That means angle A is 73.06 degrees. Now, what we're wanting to know is, could it have swung out in order to be a different angle? So here's what you determine. So the first step in determining an ambiguous case is you're going to subtract that angle from 180 degrees. And you will get 106.94 degrees. Now, to know if that's possible, what they're basically saying is this could either be 73.06 degrees or it could be 106, meaning if you were to draw this out, and this can now be 106 degrees in that case. So 73 could possibly be that angle, or it could possibly be a obtuse angle, in which case little c will change value, which means angle C would also change value. So here's what you have to do in an ambiguous case. You're actually going to have to create two completely separate triangles. You're going to find all of the answers based off of 73 degrees, and then you're going to find all of the other answers based off of 106.94 degrees. So again, we found this angle by subtracting 180 minus 73.06 in order to find 106 degrees. So we're going to go over here. We are going to continue this triangle as if it's 73.06. So the second step we're going to do is go ahead and find angle C, 73 degrees and 61 degrees, and then subtract from 180. So therefore, angle C is 45.94. So now we can find little c. So sine of 61 over 32 equals the sine of 45.94 divided by little c. Cross multiply. And divide. And you will get 26.29. So if angle A is 73 degrees, then angle C is 45 degrees and little c is 26.29. However, if angle A is 106.94, that means angle C is 12.06 degrees. You add your two angles together and subtract from 180 and you'll get 12.06. Now, sine of 61 over 32 equals sine of 12.06 divided by little c. Cross multiply. And divide. And little c would then be 7.64. So in ambiguous case, there's a chance of having just one answer. There's a chance of having no answers, which is where you would get an error in the calculator. Or there's a chance of actually having two completely separate triangles. So we are going to attempt this one to see which is going to give us, the first we're going to determine, is this a side-side angle? And if it is, we are going to go ahead and attempt to see if this is an ambiguous case. So we're going to draw a triangle. So if that is B, that is B. And if that is A, that is A and C and little c. Okay, we have an angle, we have its opposite side. So we can automatically go ahead and put together a proportion. So the sine of B over B is going to equal the sine of A over A. Put this in the calculator first. And we will get 2.29 is equal to the sine of A. In order to find the angle, this is where you would take the inverse. So you would take the inverse of sine of 2.29. And if you were to do that, you would get an error in your calculator, which means you cannot actually take the sine of that number, which means that this is not possible. There is no such triangle that can be created from these links. Now, I'll go ahead and tell you a hint. Anything over the number 1, you will not be able to take the sine or cosine of. In this case, it doesn't matter. This is a law of sines. But the cosine is the same way. You cannot take a number that is higher than 1, and here's why. When you think of SOHCAHTOA, we talked about how the hypotenuse has to be the largest side. Well, if you were to get a ratio of something that is higher than 1, that means that in a right triangle, the hypotenuse would not be bigger than the other sides, and that's not possible. That cannot be created. So sine or cosine can never be greater than 1, the inverse of it. Tangent, it does not matter, but sine and cosine, you cannot have the inverse of anything that is bigger than 1.